We're going to use similar triangles to find some missing measurements in a triangle. The situation we're going to look at is where we have two separate triangles. We're going to attack this guy with a word problem that's fairly familiar. We have a shadow type question. So we want to know the height of a tree, and we know the height of a person standing near the tree. We also know the length of the shadow of the person and the length of the shadow of the tree. And we're going to put this all together with some triangles, and we're going to be able to find the height of the tree. So first of all, we need to actually create some triangles. Here I have Tina, and I have my tree, but I don't have a triangle in this picture yet. So we're going to create the triangle. One side of the triangles will be the height of Tina and the height of the tree. Another side of the triangle is the length of the shadow on the ground. So this is Tina's shadow on the ground, and this is the tree's shadow on the ground. And the third side of the triangles is formed by the sun's rays, the sun's rays hitting Tina, and that's the path that it takes, and likewise with the tree. So we can just kind of complete the triangle with that third side. There's a couple of assumptions that we have to make when we're dealing with these questions. We're going to assume that whatever objects we have, if it's a tree or a flagpole or a building or a person, that they're standing straight up so that they are meeting the ground at 90 degrees. So that's a fair assumption you can make, that the things in your situation are not leaning, they're standing straight. And we're also going to assume that the angle that the sun hits the objects at is the same. Because the objects are in the same area, they're near each other, and the sun is very far away, the angle that the sun hits these with will be the same. I mean, it's not the exact same because the objects are not occupying the same space, but because they're near each other and the sun is so far away, you can assume that that's pretty much the same angle, and that's not going to be a problem for your calculations. So now that we have that sorted out, we can go ahead and put in our measurements. So we know that Tina is 2.1 meters tall, and her shadow was 3.3 meters. The tree, we don't know how tall it is. We'd like to know, so we'll call that X, and its shadow was 8.7 meters. So now we're all set up, and we can go ahead and start to solve our problem. We're going to make a proportion using the ratio of the tree's height to Tina's height, and then the ratio of the two shadow heights. So I always start with the thing that I'm looking for. I want to know that tree's height, so I'm going to start with that. My tree's height, I call it X because I don't know what it is yet. And this side of the triangle corresponds to Tina's height. I know that because I have my right angle on one corner and I have my sun's ray angle here, likewise with Tina. So I can see that that's the same. That's not the same, it's corresponding. So X over 2.1 equals, since X was on top of this ratio, I need another side from that same triangle to be on the top over here. So X is my tree. The only other side I know, of course, is the shadow of the tree. So 8.7. And then the corresponding measure will be Tina's shadow, 3.3. Then I'm going to go ahead and cross multiply. So I'm going to do X times 3.3. We'll just do 3.3X. And we're going to do 8.7 times 2.1. So 3.3x, we just have to do that multiplication, is 18.27. So I'm almost there. I know that 3.3 times x is 18.27. I just need to know what x is. So I'm going to divide both sides by 3.3 to undo that multiplication. And then I get that x is 5.5. So to answer my question, I've done all the work. Now I need to answer the question. The question was, how tall is the tree? So I need to say in the end, the tree is 5.5 meters tall.